Hello once again, everyone. This is Mr. Everett, and we're in the final stretch. We're in 3 of 3 of Pythagorean theorem. Today we're going to solve problems using the Pythagorean theorem. Let's get started. Again, this is the third. First, we learn how to model the Pythagorean theorem using the area of the squares of the sides. Second, we learn the converse, which is if you give me 3 sides to a triangle, I can tell you if it's a right triangle by using Pythagorean theorem. And once again, Pythagorean theorem is all about right triangles, not just any triangle, but a right triangle. We know a right triangle by the little square in the corner because that represents 90 degrees. And again, with the converse, we could figure out if it was a right triangle, but most cases they're going to tell you whether or not it's a right triangle. And that's denoted by this here. So now we're going to solve them. If you give me any 2 sides, I can find the third. So let's get started. Again, here's our objective, using the Pythagorean theorem to solve problems. Vocabulary, right triangle, legs, hypotenuse, and we're going to use the converse a little bit to solve them as well. Quick review. Pythagorean theorem says that in any right triangle, the square of the lengths of the 2 shorter sides, the square of the longer side is the sum of the square of the 2 shorter sides. Remember, short squared plus short squared equals the long one squared. Again, a right triangle is a triangle which its interior angle is 90 degrees. The interior angle is 90 degrees. The hypotenuse is the longest side, and we usually call that C. That's the C in C squared. And again, you always know what the hypotenuse is because it's always opposite the right triangle. So if there's ever any doubt which side is longest, if they give you the right triangle or the right angle, the side opposite the right angle is always your hypotenuse. And the 2 legs are the sides that form the right angle. When these 2 legs come together, they're forming the right angle. All right, so let's jump right into it. I'll let you start off. I have a right triangle here with sides 6, 10, and this side B. Use the Pythagorean theorem to figure out what the length of side B is. Okay, once again, there's no mystery here. They tell us it's a right triangle. So all I have to do now is look at the a squared plus b squared is c squared. So a squared plus b squared is equal to c squared. And you say, well, maybe it's not obvious that this is longer than this one. Well, you know what the hypotenuse is. It's always across from the right angle. So that means that's c. Since they already called this b, we're going to call this a. So let's plug our numbers in. So 6 squared plus, I don't know what b is yet, so that's b squared equals 10 squared. 6 squared is 36. I still don't know what b squared is yet. That's 100. Well, now we're back to a 2-step equation. To get b squared by itself, I need to subtract 36 from both sides. So b squared is equal to 64. And remember we talked about inverse operations, and we didn't mention it a lot, but really the inverse of squaring a number, the inverse would be the square root of that number. Inverse. So if b squared is 64, then b must equal to the square root of 64. So b is equal to 8. Actually, let's that may have been a little confusing. Just know the inverse of square number is the square root of the number. All right, so my side length must be 8. I'm going to check that. 6 squared plus 8 squared doesn't equal to 10 squared. 36 plus 64 doesn't equal to 100. Yes, 100 equals 100. So it checks out. All right, example 2. I'll do this one with you. A 15-foot ladder is leaning against a building. The base of the ladder is 30 feet from the building. What is the vertical distance from the ground to the top of the ladder? So a ladder is 15 feet. There's my symbol saying I have a right triangle. Let's look at a few vocabulary words. The base. Where's my base? My base is down here. Is 9 feet from the building. Vertical. Vertical is up and down. Remember, if I have the sun coming over the what? Horizon. That's horizontal. So vertical is up and down. Horizontal is side to side. So what's the vertical distance on the ground top of the ladder? Now that I got you started on that, let's see if you can pause the video and finish it up for me. Okay? So basically all we have here is a right triangle. I'm not very good at writing with this thing. I'm drawing. So basically we have let's try it again. Still the right triangle. We have a right triangle. We're trying to find x. This is 15 and this is 9. So what we do? A squared plus b squared equals c squared. C is the side opposite the right angle. So that means that I'm trying to, C is 15 squared. C is 15, so I have 15 squared there. Doesn't matter, I can call this A or B. I'll call it A equals 9. So now I have 9 squared plus, and I'll go ahead and call it x squared since I have x there. All right, so now again, I just solved 9 squared is 81 plus x squared, and 15 squared I think is, I forgot what 15 squared is. 15 squared, yep, 225. I'm trying to get x squared by itself, so I'm going to subtract 81 from both sides. So x squared is equal to, I won't try and do that in my head, minus 225 minus 81 is 144. So that means that x is equal to the square root of 144. X is equal to 12. So that means the vertical distance is 12. So basically, again, all this right here, all these words basically breaks down to a right triangle with the short side of 9, hypotenuse of 15, find the other short side. Short squared plus short squared is long squared. Pythagorean theorem. All right, I'll let you do this entire problem by yourself. So pause the video, give it a few minutes, and restart when you're ready to see the answer. All right, Payla's putting baseboards on her room. The sides of the room are 8 feet and the diagonal is 17 feet. What is the perimeter of the room? You're going to see this word a lot, diagonal. So anytime you have a rectangle or square, the diagonal cuts across. Okay, that's your diagonal. can't write it small here. So that's your diagonal. D-I-A-G-O-N-A-L. That's your diagonal. It cuts across here. So again, if you look at this one, you basically have what? A right triangle. From here to here to here. Again, I did a terrible job of drawing. Have to excuse me. So we'll erase that. But I believe you see it. So I have a right triangle. So that must be my hypotenuse. Since it's a right triangle, I know that a squared, short side, plus the short side squared, short side squared plus the short side squared equals the long side squared. The leg squared plus the leg squared is a hypotenuse squared. I'm going to call this one A. And this is my hypotenuse. So 8 squared plus, call that B. B squared equals 17 squared. 64 plus B squared equals, what's 17 squared? 289. Right? And then I subtract 64 from both sides. And that gives me 225. So B is the square root of 225, which if I remember correctly is 15. Alright, so it says what's the perimeter? Perimeter is what? Distance around. So I'm 8 here, I'm 15 here, I'm 8 here, I'm 15 here. It's a rectangle, so that's the same as that one, and that's the same as that one. So my perimeter must be 2 times 8, because I have 8 twice, plus 2 times 15, because I have 15 twice. So it's 16 plus 30 equals 46 feet. So my perimeter is 46 feet. So I used Pythagorean theorem to find the length of the side and add up all my sides, and I got 46 feet. Remember, diagonal. We have a rectangle or a square, doesn't matter. Could be a square, that's a diagonal. It could be a rectangle, that's a diagonal. These are both diagonals. All right. Just real quickly, the hint for this one, make sure you draw a picture so you can see it, and go ahead and tell me what you come up with. Alrighty, did you draw a picture? I cheated a little bit. Here's my picture. So both a plane and a helicopter both start at the same point, the same airport, I'm sorry. The helicopter flew 5 miles due north. Now if you remember, this is north. Opposite of north is what? South. Then you have the east side and you have the west side. So a helicopter flew north 5 miles, and it says due north. All right. So due north, we're going to assume it straight up, so that means we have a right triangle. While the plane flew 12 miles due east, so it went straight this way. So due and due. When it says due and due, that means they went straight across. So start here, straight across, start here, straight across. That gives me a right angle, so that means that I'm trying to find the hypotenuse. We know it's a right. They formed a right triangle. So now it says how far apart are they. So when up straight here, how far apart are they? Right triangle, a squared plus b squared equals c squared. Short squared plus short squared equals long squared. I'll call this, doesn't matter, but I'll call that A, and I'm going to call that B. So 5 squared plus 12 squared equals C squared. 25 plus 144 equals C squared. (25 plus 144 is 169 equals C squared, not C. Now I have to take the square root. So C must be the square root of 169. And is that 17? No. What's the square root of 169? Oh, it's 13. We should know these by heart, shouldn't we? Equals C equals 13. Let's go back and make sure. Did they ask for perimeter? No, they just said how far apart are they. So they are 13 miles apart. All right? Did you get that one? Try another one. If the area of a square picture frame is 121 square inches, what's the best estimate of the length of the diagonal of the picture frame? All right. Pause. And remember, we already talked about diagonal. Didn't matter if it was a square or a rectangle. So my suggestion is you draw a picture of this and see what you come up with. All right, again, this is why your paper should always be dirty. Draw a picture. I have a square. Diagonal. How long is my diagonal? All right, now here's a trick here. It says a square of 121 inches. So my area is 121, and it's a square. Well, what did we say the relationship was? Well, if I have a square and my area is 121, then my side must be the square root of 121. See, we can't forget these things. So that means my side is 11. That means that's 11, that's 11, and that's 11. So I have a side 11, a side 11, and it's a right angle. So this part right here is a right triangle with a short, short, and long. So if I want to find out the best estimate of the diagonal, I take a squared plus b squared equals my diagonal squared. Then just take the square root and I got my answer. So I got 11 squared plus 11 squared is my diagonal squared. 121 plus 121 is my diagonal squared. 242 is my diagonal squared. So my diagonal must be the square root of 242. Let's look that up or calculate that. And I get on my calculator, oops, and I get 15 and a half, which is closest to 16. So it just keeps on going. Dot, dot, dot. All right. So again, diagonal, the line that cuts across either a square or rectangle. And it was a square. So they gave me the area of a square. Now I remembered from a long time ago, or maybe a month or two ago, that the relationship between the side of a square and the area of a square is the side is the square root of the area. So all my sides were 11. It was from the right angle, so that was my hypotenuse. I was trying to diagonalize my hypotenuse, and I solved for it. All right, this last one. I'm going to draw the picture for you. Go ahead and read it and see what you can come up with. All right, last one. One morning, Carla's mother left home and drove 9 miles north to drop Carla off at school. Then she drove 6 miles west to the store and returned home by the shortest route. To the nearest 10th mile was the total distance Carla's mom drove that morning. All right, so I drew a little picture. One morning, Carla's mom left home and drove 9 miles north. She drove 9 miles north and then drove 6 miles west and then drove home the shortest route. To the nearest 10th mile, what's my total distance she drove that morning? So total distance would be the 9 plus the 6 plus the x is my total distance. But I don't know what my x is. All right. But by looking at the picture, I'm going to say this is a right triangle. And then I'm going to figure out what x is. Okay? So let me make a little room here to do some work. You can keep it somewhere on your paper, but I have to erase it for have a little work area. All right, so, oops, don't want highlighter. So a squared plus b squared equals c squared. I'm trying to find c. So I got 9 squared plus 6 squared, and we'll call it x since we start off calling it x. So 81 plus 36 equals x squared. That gives me what? 81 plus 36, 7, 11, 117 is equal to x squared. So that means x is the square root of 117, which we will now calculate. Which is 10.81. It's irrational. So to the nearest tenth of a mile, if I rounded this, it would come out to 10 8/10. So my total distance would be 6 plus 9 plus 10 8/10. I'm going to hold my decimal place here with 0. 8, 15. Carry my 1, 25 8/10. So my total distance equals 25 8/10 miles. All right. So that was just the third leg in our Pythagorean theorem trilogy, if you will. We modeled the Pythagorean theorem, and we introduced the converse of the Pythagorean theorem, and then we put it all together to solve problems using the Pythagorean theorem. So go ahead and do your practice problems, and then when you're done with all that, you'll have a quiz. Talk to you soon.